So here we're trying to find arctangent of the square root of 3. Another way that we can write this is tangent of what value is equal to the square root of 3. And that just means that when we look at a point at a unit circle, we're really just trying to find what point where I can take y over x is going to give me the square root of 3, right? And so this is our unit circle. Now, I don't want to write out all the points. And in order to narrow down the quadrants as to what points are going to be the ones that we're going to choose, we can remember a star point, which is what I like to call the things that we have to just know to solve these problems, is the range of the function that is arctangent. And so that is negative pi over 2 to pi over 2. And another thing you need to know is the unit circle. So negative pi, well, actually pi over 2 is over here, and negative pi over 2 is over here. Given that information, we know that the y values, right, or any values that arctangent could actually be, are only going to be in these quadrants over here, from negative pi over 2 to pi over 2. And so they can't be in this quadrant and they can't be in this quadrant, so there's no point in writing out any points there because those points are not going to be used. Now, the next step is to actually write out the points that are in the quadrant 1 and quadrant 4. So there's 3 main points in every single quadrant in the unit circle. And I usually start with like an x, right? So it's going to be half an x this time because we're not really doing the whole thing. But the x, right? Every x ends with the 4 in the denominator. And every x has a pi at the top. And then, let me just erase this already. The way that I know the numerator is from a girl on YouTube. So 5 days a week, I go to 7, 11. And so the numerator for this one is 7. Okay, and then the rest of them, I like to think of, well, they all have pi, right? And I already said 7, 11, right? So 5, 7, 11. And then the way that I think of the denominators are either going to be 6, 4, or 3. And the way that I memorize that, well, that's just a me thing, the way that I memorize it, because I do 3D modeling. So I like to think of like 3D and then Cinema 4D, which is like a 3D platform. And then 6, I don't even know what I was thinking with 6. I don't remember, but I now just memorize 6, 4, 3. So that's how it makes sense to me. That's how I make it make sense to me. For me to remember it. So those are going to be the denominators. Now, what order? How do I know if it's like 3, 4, 6, or is it like 6, 4, 3? Like, what order do I do it, right? And so I like to memorize it this way. So the top, if I'm finding a denominator in the top quadrants, I like just to think of these arrows, right? So anything in the top is just trying to get together at the top, and anything at the bottom is just trying to get together at the bottom. So I just start at the starting points, right? Which are over here. So this is 6, and then 4, and then 3. And then here I start at the starting point. Well, that doesn't really matter. Let's look at this one. This one's the starting point, so I start over here, 6, 4, 3. So I always think 6, 4, 3, and then the way that I do it, the direction, just depends on these arrows that I like to think about. And those are the points. I mean, well, no, those are the values. Now we actually do the points. So again, the points I actually get by starting with my x's. So I know that any part of my x's is going to be square root 2 over 2. So, right, this is an x, right, part of my little x over here. And then this one's also square root 2 over 2. But the signs are different. This is actually negative y over here. And then the way that I know the other points is, first of all, I know that they all are going to have a denominator of 2. And then the numerators. So here's the thing. I only do like the first ones, the x values. I think of 3. Well, I don't really think of, well, The only ones that we need to know, obviously besides square root 2 over 2, is square root of 3 and then 1. And I know that if this is square root of 3, then 1/2 is the opposite, right? There's never going to be a square root of 2 over 2 next to a square root of 3 over 2 or a square root of 2 over 2 next to a 1/2. It's just these are always together and then square root of 2's are always together, right? And so then this, oops, is just the opposite. And so the way I know the order, right, is I just like to think of 3, 2, 1, but again, I follow the arrows. And then over here, um, this is square root of 3. So this is 1/2, and this is 1/2 square root of 3. So to put things back into perspective, we're really looking for a value, which can be any one of these, right? Where if I take their y value, right, and I put it over their x, it's going to give me square root of 3. So we really have to just do it for each one at this point. I like to obviously pick ones that have 3 in it. So I'm going to pick this one, and this one, and I'm going to try those out. So let's start with pi over 3. So we have 1/2, right? Or we're actually supposed to take y. So let's do square root of 3 over 2 over 1/2. So with some basic algebra, we know that this is just the same thing as square root 3 over 2 times 2. So really this is just 2 times square root of 3 over 2. These cancel out and we're left with the square root of 3, which is amazing. So this point does work so far. So we have pi over 3 as one of our options. Okay? Then let's try pi over 6. So pi over 6, we have 1/2 as our y, and then we have square root of 3 over 2 as our x. And so this is the same thing as saying 1/2 times 2 square root of 3. So when we do the math, we have to rationalize this denominator real quick. So this just becomes square root of 3 over 3. That's how we rationalize 2 square root of 3. This becomes, right, 3 squared, and then a square root and a square cancel out. So that's why it's 2 square root of 3 over 3. And so, remember, this is just this, and so we still have to multiply it times 1/2. And so that is 2 square root of 3 over 6, which is 1 square root of 3 over, oops, 3, which is just square root of 3 over 3, which is not equal to the square root of 3. So which one was this? Pi over 6? So it's not pi over 6. Next we have 7 pi over 6. So it's 1/2 over square root of 3 over 2. That's the same as 1/2 times 2 over square root of 3. Again, we have to rationalize the denominator. Did I forget the signs? I did forget the signs. This is negative. Oh no, I didn't. I'm so confused. This is negative. Yeah, I think everything else is fine. So yeah, it's the same thing. Good thing I caught that. So it's negative 1/2 over square root of 3 over 2, which is the same thing as negative 1/2 times 2 over the square root of 3. We rationalize the denominator, so we're going to do that over the side over here. So multiply by a fancy 1, 2 square root of 3. This becomes 3 squared, cancels out, which becomes the following. So it's really just 1/2 times 2 square root of 3 over 3. Then that just becomes negative 2 square root of 3 over 6, which is negative 1, 3, over 3, which is negative square root of 3 over 3, which is not equal to the square root of 3. So 7 pi over 6 is also on the not option. Then finally we have, what is this one? 5 pi over 3. So this is negative square root of 3 over 2, right? Over 1/2, which is the same thing as negative square root 3 over 2 times 2, which is negative 2 square root of 3 over 2, cancels out, negative square root of 3, and that is not equal to the square root of 3 because it's negative. And so that one as well is not an option. So 5 pi over 3 is not an option. And so we only have actually one that works. But before we say that that's the answer, we want to double check that that's within the domain and range of arctangent of square root. So we only have one that's left, but before we say that that's the answer, we want to double check that this point is actually on the function of arctangent, right? So we know that it does fit the range, right? So now we only have one point left, which is this one over here, but we want to make sure that before we say it's the answer, that it's actually lies. So we only have one point left. But before we say that's the answer, we want to make sure that this point actually lies on the graph of arctangent. And so how do we do that? Well, we look at the domain and the range of arctangent. This is something you have to know. The domain is all real numbers. So it could be any x value, so let's check. And then the y value has to be between, well, let's take a look at what pi over 2 is. So pi divided by 2 is 1.5. So we're really saying that the range has to be between negative 1.5 to 1.5, right? And square root of 3 over 2, let's look at what that one is. So 0.9 is between negative 1.5 and 1.5, and therefore our answer is pi over 3, which is basically saying the arctangent of square root of 3 is equal to pi over 3.